Jupiter is almost 600 million miles away from the Earth. However, one of its moons is giving scientists sleepless nights here on Earth. This moon has been sending strange and mysterious messages to NASA's Juno probe. Which moon is sending these messages? Is it aliens trying to communicate with us? What is the message saying? In this video, we dig into NASA's recent announcement that one of Jupiter's moons has started to send the Juno probe messages and other mysteries of deep space. Jupiter as a planet stands out for many reasons in the solar system. For example, the planet is the largest, so huge that it's twice as massive as all the other planets combined. With a radius of 43,440.7 miles or 69,911 kilometers, Jupiter is 11 times bigger than Earth. To put this size disparity in perspective, if Earth were the size of a nickel, Jupiter would be about as large as a basketball. Jupiter has an average distance of 484 million miles or 778 million kilometers from the Sun, or about 5.2 astronomical units. 1 astronomical unit, or AU, is the distance from the Sun to Earth. From this distance, it takes sunlight 43 minutes to travel from the Sun to Jupiter. What else is special about this jumbo planet? Jupiter has the shortest day in the solar system. A day on the planet is only 10 hours, which is the time it takes to complete a spin. However, because of its huge distance from the Sun, a year on the planet is the equivalent of 12 years on Earth. Jupiter is an old-timer. It formed along with the solar system some 4.5 billion years ago, when intense gravity pulled swirling gas and dust into a planet. One interesting fact is that Jupiter used up most of the leftover materials after the Sun was formed. As such, Jupiter has the ingredients of a star but never grew large enough to trigger reactions that would have produced heat and light as stars do. Because of its origin, Jupiter has mostly the same materials as the Sun, made of hydrogen and helium. However, deep in the atmosphere, pressure and temperature increase, compressing the hydrogen gas into a liquid. This gives Jupiter the largest ocean you will find in the solar system, but instead of water, the ocean contains hydrogen. At depths of about half the distance to its center, the pressure becomes so great that electrons are squeezed off the hydrogen atoms, making the liquid electrically conducting like metal. Helping matters here is how Jupiter's fast rotation is thought to drive electrical currents in this region, generating the planet's powerful magnetic field. As such, Jupiter has the strongest magnetic field of any planet in the solar system. It is about 20,000 times as powerful as the Earth's. Jupiter is festooned in rings, although it came as a complete surprise when they were discovered by NASA's Voyager 1 in 1979. The rings contain particles that are small, dark, and difficult to see. However, you can't talk about Jupiter without mentioning its moons, and it's one of them that is giving NASA scientists sleepless nights. Jupiter is known as a miniature solar system because of its numerous moons. The exact number of moons attached to this planet is a moving target as scientists keep discovering more. To date, not less than 79 moons have been found orbiting Jupiter. Its large mass, more than 300 times the Earth, gives it the stability to exert gravitational force over a large area and keep multiple moons in place. The 4 largest Jupiter moons are known as Galilean moons because they were discovered by Galileo Galilei. They are named Europa, Ganymede, Callisto, and Io. In the order of arrangement, Callisto is the furthest from Jupiter. It is also the smallest of the 4 and the most heavily cratered object in the solar system. It's about the size of Mercury but endures the least magnetic force from Jupiter. Ganymede is next to Callisto and is the largest of the quartet. It has the distinction of being the only known moon in the universe to have its own magnetic field. Europa comes next with a size similar to the Earth's moon. This satellite is full of cracks and streaks on its icy surface and has a high degree of reflectivity, making it one of the brightest moons in the universe. Europa is intensely studied by scientists because it's suspected to harbor an ocean beneath the ice that might contain life. And closest to Jupiter is Io, and this is the one that has scientists on the edge of their seats. Io is as violent as it can get. This moon is actually the most volcanically active body in the solar system. Its surface is covered with hundreds of volcanoes, spewing sulfurous plumes hundreds of miles high. Sandwiched between Europa and Ganymede, Io is used to fighting for its life as it negotiates the gravitation tug-of-war between the 2 moons and Jupiter itself. These tidal forces are responsible for the massive heat driving Io's intense volcanic activity. Io has an ever-changing landscape as fissures ooze lava onto the moon's surface, filling impact craters and creating new floodplains of liquid rock. Scientists are yet to determine Io's exact composition, but it's suspected to be molten sulfur and its compounds or silicate rock. However, the moon's thin atmosphere is primarily composed of sulfur dioxide. While the volcanoes on Io can reach 3,000 degrees Fahrenheit, Io's surface temperature is about -202 degrees Fahrenheit. Because of these extreme temperatures, Io is sometimes called the celestial body of fire and ice. Io is about the same age as Jupiter, which it orbits at about 262,000 miles. The orbit lasts around 1.77 Earth days. The moon has a mean radius of 1,132 miles, a bit larger than the Earth's moon. You may notice from the pictures that Io is not perfectly spherical, but rather oblong. Here is the reason. As Io orbits Jupiter in an elliptical fashion, the strength of Jupiter's gravity on the moon varies depending on how close it is to the planet. This gravitational fluctuation causes a never-ending push and pull on the moon's interior in different directions, and this causes Io's surface to bulge by as much as 330 feet or 100 meters. This movement causes Io's rocks to grind past each other, generating vast quantities of heat, 20 times more heat flows than Earth. If Io were Jupiter's only moon, its orbit would have likely settled down into a circle a long time ago, but poor Io is destined to eternal outward tug from Europa and Ganymede. Io might be small, but it exerts its own influence on Jupiter, and it gets electrifying, literally. You see, Io's orbit cuts across Jupiter's powerful magnetic lines of force, turning Io into an electric generator. Io can develop 400,000 volts across itself this way, and that could create 3 million amperes of electrical current. Ironically, this then makes its way back along Jupiter's magnetic field lines and causes lightning storms in Jupiter's upper atmosphere. But there is more to the relationship between Jupiter and Io. As Jupiter rotates, it is at a personal loss to Io, as the magnetic forces strip away about a ton of its material every second. The material liberated becomes ionized and forms a donut-shaped cloud of radiation called a plasma torus. Some of the ions are pulled into Jupiter's upper atmosphere and create auroras. An example of this activity was spotted by the Hubble Space Telescope, which revealed the influences of Io and another Jovian moon at Ganymede in Jupiter's auroras. Io has many tricks up its sleeve, and the latest one is what is baffling scientists. Thanks to NASA's spacecraft Juno, they have been listening in on radio emissions coming from Io. So what exactly is going on Io? Remember how we said that volcanoes are abundant on this moon and it is subjected to the effects of Jupiter's magnetic forces, and that Io loses 1 ton of gases and particles per second into space, and that they become ionized when they split into ions and electrons and rain down on Jupiter. Well, when the electrons are caught in the magnetic field and accelerated towards Jupiter's pole, they generate something scientists call decimeter radio waves, decimetric radio emissions, or DAM. When Juno is properly positioned, its instrument can pick up these radio waves. Using this data, researchers have pinpointed where in Jupiter's massive magnetic field the radio emissions come from. The data has also shed light on the behavior of the enormous magnetic fields gas giants create. According to the research team, the radio waves come from a space that can be described as a hollow cone where the conditions are just right, the right magnetic field strength and the right density of electrons. The signal rotates like a lighthouse, and Juno picks it up only when the light is shining on the spacecraft. The radio data also show that the electrons that create these radio waves emit a massive amount of energy, which turned out to be 23 times greater than researchers thought. They discovered that these electrons could come from other sources too, such as from the planet's magnetic field or from solar winds. Not very far from Jupiter, Uranus is also behaving mysteriously. While the planet orbits even farther from the Sun than Jupiter, a strange heat wave is causing Uranus's rings to warm up, despite being so far from the Sun. This was discovered in new heat images of Uranus obtained by 2 ground-based telescopes in Chile. The telescopes revealed the temperatures of the rings for the first time, and it was -320 degrees Fahrenheit. This is the temperature at which liquid nitrogen boils. That might be extremely cold by Earth standards, but out there in space where the temperature can approach absolute zero, which atoms cease movement altogether, Minus 320 degrees is quite warm. Uranus is so far from the Sun that it only receives a fraction of the heat from the Sun that the Earth receives. The ice giant orbits the Sun at an average distance of 19 AUs. So just what is causing this relative warmth? Scientists still don't know, but the strange temperature proves that the brightest and densest ring at Uranus, or the Epsilon ring, is very different from other ring systems in our solar system. Every giant planet in our solar system, that is Jupiter, Saturn, Uranus, and Neptune, has its own set of rings, but out of all of them, Saturn's rings are the most spectacular and best understood. That's because they're easily visible even with just a small telescope, and because NASA's Cassini mission studied them up close. But Saturn's rings are quite different from those of Uranus. But if they could solve the mystery of the warming temperature,